Alright, so as we talk about our proofs and proving certain information, we're going to come across polygons that have certain relationships that we can use to prove certain things when it comes to angles and transversals and all kinds of different things like that. One of the main things that we'll be able to use, one of the main four-sided polygons that we'll be able to use is a parallelogram. The nice thing about a parallelogram is it is a quadrilateral, which means it does have four sides. Parallelogram, obviously, the first thing you should kind of hear there is parallel. And a parallelogram just means that we have a four-sided figure that's got two sets of parallel lines. So that's our first set that we can see here, and my blue lines will be my second set that we can see here. There's a lot of different properties of parallelograms that we'll be able to use when proving things and when going about solving different things in parallelograms. If we look, there's 6 important properties of parallelograms that you need to know. And I have them numbered wrong, but if we look at them, now we can see there's 6 of them. So the first 2 are up here, and there's an illustration with them. Just because they're pretty easy to see. The opposite sides of parallelograms are going to be congruent, which obviously means they're going to be equal. So if we look at this picture, AB, so A, B, the line connecting A and B, is going to be congruent to line D, C. So I have these 2 lines are going to be congruent. Now at the same time, I know that line A, D, and line B, C are going to be congruent as well. And make sure that you notice those congruent marks in there. That just means that any mark there that has one mark is congruent to each other, so those opposite sides are. And then this one, you can see that the double marks are going to be congruent to each other, so those double marks are going to be equal as well. And that's just a visual way to represent that congruence. The other thing that we can notice is that opposite angles in a parallelogram are going to be congruent, which means those measures are going to be equal. So that's something else that we'll be able to look at and see there, is that those opposite angles are going to be congruent. Number 3 tells us consecutive angles are going to be supplementary. So if I look back at my image up above, I have consecutive angles. So if I look at my angle A and angle D, consecutive just means they're 2 in a row. That means that these 2 angles are going to be supplementary, which means they're going to add up to 180 degrees, which will make sense because essentially they're half of this parallelogram. If a parallelogram is 360 total degrees, half of it we know has got to be 180 degrees. Another thing is, I don't have a visual of it, but it kind of makes sense, is if one of the angles is right, then all of them have to be right, which makes sense because if I've got a parallelogram that looks like this, and I know this is a right angle, I know the opposite has to be the same, and I know that consecutives have to be supplementary, so that would end up giving me something where I'd have a rectangle or a square. Another thing I know is the diagonals of the parallelograms bisect each other, which means they cut each other in half. So these 2 diagonal lines would be my pink one and my orange one. They bisect each other. They cut each other in half directly. The other thing they do is they cut these angles in half, because remember, that's what a bisector does. It cuts those angles in half. Then the last thing we see here is each diagonal of the parallelogram completely separates it into 2 congruent triangles. So if I just look at this one, my bisector cuts this up into 2 triangles that are essentially congruent. The last thing, I don't have it on here, but what we can kind of piggyback on from our last lessons are if we have two parallel lines, which a parallelogram has, and we have this transversal cutting it, this creates our transversal relationships here, which we just discussed, which would be our same side interior, our corresponding angles, our vertical angles, our opposite interior angles. All of those angle relationships that we just defined in our last unit now come into play because we're working with two parallel lines and a line that is going to be transversing them. A rhombus is a special type of parallelogram. Really, the only difference between a parallelogram and a rhombus is a more specific type of parallelogram where all of the sides are equal. So all of these sides are going to be equal, which means all of the bisectors are going to be equal as well. So a rhombus is a pretty particular type of parallelogram. Another parallelogram, or I'm sorry, not a parallelogram, but another quadrilateral that has another relationship or set of relationships would be a trapezoid. And a trapezoid is when one pair and only one pair of the sides are parallel, and the other two legs obviously are not. So we could see this would be a trapezoid where I have two parallel sides, and then my legs obviously here, these two are not parallel, which would make this now a trapezoid. And I can have an isosceles trapezoid, which means I've got my two parallel lines and then my two legs. These are my legs. My two legs are going to be congruent, which means they're going to be the same measure. And then my last example here is if I'm looking at an isosceles trapezoid, I can talk about this median line. This median line is going to be the midway line. And I have one special relationship which tells me that the measure of this median line is just really going to be the average of this line and this line. So if I take AD and I add it to BC and multiply by 1/2, which is I'm just taking the average of it, then that should give me the measure of my median line there. And that'll be used seldomly just to solve problems and even to create relationships, but it's not used very often, but it is a nice thing to know.